Hello, PreCalculus. Welcome to the second part of section 1.7. In today's notes, we are going to find the composition, verify that two functions are inverses of each other. We're going to use that with composition of functions. And the second part is we're going to find inverse functions graphically. So, example number 1, we want to show that f of x, which is equal to 6 over x minus 4, and g of x, which is 6 over x plus 4, are inverse functions. And we're going to use composition of functions to do that. And we can do that because if two functions, f and g, are inverses of each other, if I find f of g of x, it's got to be equal to x for every x in the domain of g of x. And if I find g of f of x, it has to also be x for every x in the domain of f. So let's look at A and see what is f of g of x. That's plugging the g of x function into f of x where we see x. So this is going to be 6 divided by, x would be this entire thing. So 6 over x plus 4. Do you need the parentheses? No, I'm just helping you see that this is really 6 over x minus 4. 6 over g of x minus 4. All right. Oh, I lost my 6. All right, and then we're going to do some, I'm going to go ahead and drop those parentheses now that we see that. What happens to the 4 minus 4? That becomes 0. So I really have 6 over x. And if I've got a fraction divided by a fraction, what do we do to get that simplified? Well, this is the same thing as 6 over 1 times the inverse of the denominator. So the inverse would be x over 6. My 6's cancel. And so I've proven that f of g of x is equal to x. Good. That's one direction. I have to show it the other direction too. In other words, I have to plug f of x into g of x. This time I'm going to take f of x, plug it into g of x. So I've got 6 over 6 divided by x minus 4, and then plus 4. So this is 6 over 1 times x minus 4 over 6 plus 4. Doing the same thing, I got a fraction. Remember, this is 6 over 1, really. Oops. So a fraction divided by a fraction. I take the first fraction, multiply it by the reciprocal of the other one, where we flip the second fraction. When we do that, the 6's will cancel out, and I'm left with x minus 4 plus 4. Minus 4 plus 4 is 0, so this is equal to x. Since f of g of x is equal to x and g of f of x is equal to x, then we have shown that these two are inverses. All right, looking at B. Okay, I'm going to show f of g of x has to be equal to x. This is going to be 18 minus 3, not times x, but times g of x. 6 minus x over 3. I'm going to go ahead and distribute that 3, so I've got 18. Leave that alone for a minute. Negative 3 times 6 would be negative 18. What about negative 3 times negative x over 3? Well, negative times negative is going to be positive. What is 3 over 1 times x over 3? The 3's cancel, and I'm just left with x. And the next step, 18 minus 18 is 0, so this guy is going to be equal to x. Oh my goodness. There we go. How about g of f of x? Now we're taking f of x and plugging it into g. So I've got 6 minus, all of f of x is 18 minus 3x over 3. I can split this up into two fractions. Be careful though, because of this minus sign, what's going to happen, remember, when we plug this in, it's really got parentheses here, right? So that negative sign has to distribute to both pieces. So it's going to be 6 minus 18 thirds. That's this piece. And then minus a minus becomes positive 3x over 3. Well, what's 18 divided by 3? That's 6. So I've got 6 minus 6 plus 3 over 3 cancels out. And we just have x left over. 6 minus 6 is 0, so that's equal to x. So we have showed that f of g of x is equal to x, g of f of x is equal to x. So these two guys are inverses of each other. All right, go ahead and pause your video right here. See if f of x and g of x are inverses and prove it with composition of functions. All right, hopefully you've paused your video and done it. Is this what you did? I'm going to do f of g of x first. So I'm going to take this guy and plug it in here. So it's going to be the square root of x minus 10 squared plus 10. Well, what happens to the square root of the square? They cancel each other out, right? So then I have x minus 10 plus 10. 10 minus 10 would be 0, and this is equal to x. All right, let's go the other direction. Now we're going to find g of f of x. And so that is going to be the square root of x squared plus 10, and then minus 10. 10 minus 10 goes away, I've got square root of x squared. Square root of x squared is plus or minus x. And so that's where this piece goes in. We only want when x is greater than or equal to 0. So the square root of a positive x is just going to be positive x. So that's why the domain is important on this. And so this is indeed inverse functions. Now I do want to say a lot of times, especially at the beginning, probably when you're in Algebra 2, you might have just written something like this down, like here, and done a whole bunch of, well, I'm not sure really how it works, but I know I'm supposed to get x at the end and gone straight to this being my answer. I will not accept that. That does not show me that you know how it actually worked out to be x. Yes, it does become x, but I need to see the steps in between that shows me that you really understand why it is x. So be careful on your test. If it's free response, you're going to have to show that to me explicitly that you understand the order of operations. In our next video, we're going to do how to find inverses graphically.